Hello everyone and welcome to Science with Elliot, and this is the first request from a school friend, and they asked me, named Sam, and very nice, and he personally asked me, he just asked me about the states of matter, like what are they, how do they work, and just how do they behave. Well, the first three that you probably learn about are solids, liquids, and gases. Solids have a fixed shape. I mean, they can move about a little bit, like if it's soft, like putty or something like that. But they have a mostly fixed shape when left on their own, and a fixed volume. They're pretty just standard. Particles can move about a bit, but in general, the atoms are bound together in a tight shape, which also varies depending on what the material is, which is very fascinating. And then you have liquids, which have a fixed volume but have a variable shape. They can flow, they can change their shape to fill a container. There's actually things like 10% of the particles are missing, but that actually allows for 70% of the remaining ones to be able to move and flow, and basically there's gaps, and the particles are basically, as you go forward, as you get hotter and hotter, it gets less dense, because solid, if you get it hotter, it melts into liquid, and liquid, as it gets colder, freezes into solid. So when it gets hotter, particles expand, leaving gaps so they can flow and move, and that's why water and everything flows. And if you get even hotter, then it basically evaporates into gas, and gas condenses back into liquid. But when you go into gas, it gets even hotter. Particles are so not dense now; they're basically so spread out that they don't have connections anymore. While they still somehow maintain a shape. Kind of, not really. Not only do they not have a fixed shape, they don't even have a fixed volume. They can literally expand or shrink to fill any container. Of course, highly denser gases obviously have a lot more pressure. And in fact, it's not just temperature. You can pretty much condense and freeze things just by purely applying enough pressure, aka squishing them enough. However, now if you get even hotter, you'll learn about something that you might have heard of, and the classic nerd pointing this out thing, plasma, which is essentially when it gets so hot that the individual within the atom, it breaks away and forms electrons. You have electrons and protons and neutrons. You basically have electrons and the nucleus. The nucleus is made of protons and neutrons. So it kind of almost becomes like a soup. It kind of becomes a nice goo. It basically becomes atom soup. Just very goo, very hot. It's basically what the sun's actually made of. The sun's not a fireball, neither is it a gas ball, it's a plasma ball. It's made of epic plasma. But there's one last thing on the hot scale, which is not really actually much. It's just plasma. There's different types. Like if it gets hot enough, it breaks up into quarks and gluons, and that's even basically then it's just almost the same, similar to entropy. But as you get hotter and hotter, you get more and more agitated, and things start to get weirder. And they say that the highest temperature you could ever reach is 142 nonillion degrees, which is 142. 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 degrees. Yes, 142 thousand, and a million has like 30 zeros. It's a very big number, and yeah, when you reach that temperature, and by that point it doesn't matter if it's Celsius or Kelvin, on Fahrenheit it'll be a lot more, but that's when physics itself just starts to be like, I'm out of here, bro, I'm out of here. But on the cold scale, if you go below solids, once you get to freezing temperatures like below minus 200, you might find the absolute zero is minus 273.15, which is also 0 Kelvin. So when you get things really low, like low double digit or even single digit Kelvin, which is like negative 260 to 70 degrees Celsius, really cold, they form Bose-Einstein condensates. Now when you were younger, you might have thought that things are just made of things, matter, it's just all just stuff, but later on you obviously learn about atoms. But a Bose-Einstein condensate is unique because it kind of just is things. The atoms become so tightly packed together that they literally just fuse and just make a pure tiny chemical block. It's just freezing, and it's literally just, it's all just condensed into one literal block of atoms. That's all just crazy. And at minus 273.15, absolute zero, the particles just stop moving. They're all pretty much condensed into one point and they're all not moving, which is obviously very different from 142 nonillion Kelvin. But yeah, that's the temperature scale from really cold to really hot, along with all the states of matter you'll find. Now there's other ones, of course, like there's many other ones, like liquid crystal and other types of things and plasma, but those are really the three main ones, plus two funny others on each end of the scale. So there you go, and thank you for watching. And remember, you matter. Unless you multiply yourself by the speed of light squared, then you energy.